Hello and welcome to my video, lesson 1.4, application of set theory. Alright, so we're going to just go into a couple examples of this, but basically we're looking at set theory with more than two sets. We're looking at three sets. This is a Venn diagram of three. And we're looking at just trying to find all of the different parts of it when we're given a set of data. So let's take a look together at what this looks like. Let's go with purple so that it's different than our colors. All right, out of 45 students surveyed, 32 said they wanted to visit Europe, 23 said, excuse me, they wanted to visit South America, 15 said they wanted to visit Africa, 14 said they wanted to visit both Europe and South America, 13 said they wanted to visit both Africa and Europe, 12 said both Africa and South America, and 11 said they visit all of them. Okay, this is what I want you guys to do. Whenever you see one of these types of questions, what I want you to do is start in the middle and then work your way out. That's what I recommend. Start in the middle and then push outwards. With all the data that you have. All right, so let's take a look at what this means. So start in the middle. Well, start with the one that says all of them. Okay, all of them would be in the middle. Okay, if there are any of them that says but not blank, that would be a really good hint that you can probably deal with it right away. But none of ours do that. So what we want to do next is take a look at the next level. Actually, first we should probably label. Let's go with Europe, Africa, and South America. Okay, so Africa and South America, so we just finished this one. So the next one says both Africa and South America. I'm going to be just working up straight away this way. Okay, we want to look at the most specific first and then the most general. These are really general, right? We want to look at those last. Okay, specific, first, general last. Okay, so 12 said both Africa and South America. Well, what does that mean? Well, that means the area bounded within this part. Okay, everywhere in here is included with Africa and South America. So 12 are all together in that area. Now, if 11 wanted to do all of them and 12 wanted to do both together, right? Then that just has to add up to 12. So 11 plus 1. Next we have Africa and Europe. So let's not check that off actually. Africa and Europe is this part. Oh no, what did I do? Oh my gosh, I thought I switched it. There you go, pen mode. Africa and Europe is this part. Okay, so that needs to add up to 13. So 11 plus 2 is 13. Last we have 14 for both Europe and South America. So we have to have 3 down here, 11 plus 3, that's this whole area, equals 14. Okay, next, going from general to from specific to general, we can look at any one of our circles we want, but let's look at Africa. Together, it needs to add up to 15, so 11 plus 2 plus 1 plus 1 is 15. South America, it has to add up to 23, so 8 should work, so 12, 15, so yeah, 8, good. It needs to add up to 23. Another way you can think about it is take your 23 and you subtract by the numbers that you have so far in that circle, in the blue circle, and so that equals 8. And then we'll do the same thing for our European circle, so 32 minus 11 minus 3 minus 2 equals 16, should be right. There you go. And we now have our full circle done, but we're not quite done yet. Actually, I don't even know if I put the right number in here. Let's see, because it says 45 students surveyed. So all of our numbers should add up to 45. So let's just go with the European circle is 32 plus everything outside of it, plus 8 plus 1 plus 1. So that's 42. So 45 minus 42. So there are 3 students outside the box, or outside the Venn diagram. All right, so hopefully this makes some sense to you guys. Starting in the specific, going to the general last. Look for words like all, both, but not. Those are keywords. All right, let's take a look at the principle of exclusion and inclusion. Here we have the formula for that with a Venn diagram. So we have A, B, and C. Okay. When it says A, it means everything in A. So the entire red circle. So that's this part. The entire red circle. B, the entire green circle. So maybe I can just go like this. Red, green, and our blue circle. Okay, when it talks about the intersection between A and B, it's talking about this part. Okay, and that's right here, so we're subtracting by that. When it's talking about the intersection between A and C, it's talking about this part. Whoops, wrong spot actually. A and C, it's talking about this part. Okay, in there. When it's talking about B and C, it's talking about this part. Inside there. And then it adds back the intersection of all 3. Well, what is that exactly? It's just the inside here. Okay, so if you're missing any one of these things, any one of those pieces of data, that's 7 pieces of data plus our total number for within all of our circles. Okay, if we're missing any one of those 8 pieces of data, you can actually find it with this formula. But you can only be missing 1 for that to work. Okay, so let's go ahead and use that, or using our going from specific to general method with the Venn diagram. Either way, and try to solve this question. Okay, now I'm going to tell you that's going to be much easier to solve with our formula. Okay, so with our formula, we're trying to solve how many own all 3 makes. That would be in the middle here. Okay, how many own all 3 makes? Well, 34 teachers have one of these cars in their household, at least one. Maybe I should write that. Own at least one of the following cars in their household. Okay, if you think you can finish this question, pause the video right here, try it out for yourself, and then press play. Okay, so what we're going to do is call Toyota A, BMW B, Chevy C. At least 2 of them line up. So we're going to say 24 Toyotas, 10 BMWs, 19 Chevys. The intersection between A and B, Toyota and BMW, is 5. Intersection between A and C, that's Toyota and Chevy, is 7. It says and. Okay, and the intersection between Chevy and Toyota, whoops, that's wrong. That meant to be Chevy and BMW, is 4. Okay, what we don't know is the intersection of all 3. We don't know that intersection. That's what we're solving for. So what we're going to do is basically move everything over. So 34 minus 24 minus 10 minus 19 plus 5 plus 7 plus 4 equals n, and then the intersection of all 3. It's really hard for me not to do a normal n. There you go. Intersection of all 3. Okay, and so if we just go ahead and plug that in our calculator, where's my calculator? Here it is. What we're going to do is just plug it all in. So 34 minus 24 minus 10 minus 19 plus 5 plus 7 plus 4 equals -3. Did I do something wrong? I thought I made it all work out. Yeah, I must have done something wrong. Okay, that's all right, that's all right, that's all right. What I'm going to do, I'm going to cheat a little bit. I'm going to make this 39. No problemo. Okay, I am cheating. Okay, at this point, it should work. There you go, 2. Sorry about that, guys. So that's with a 39 instead. Okay, so we now have an idea of what the intersection is like between all of them. I thought I checked this beforehand. Huh. So we have an intersection of 2. Okay, that's for all 3 makes. So that's 2 right here. Okay, now what we can do is solve for like going from our specific to our general. So if we're talking about Toyota, BMW, and Chevy, what we can do is we can go Toyota and BMW, so that's the green and the red part. This intersection is 5, and there's already 2 there, so let's put a 3 here. All right. Next we have, so that's this one. We can also look at Chevy and BMW is 4. Chevy and BMW is 4, so there should be a 2 here. Toyota and Chevy is 7, so there should be a 5 plus 2 is 7 there. So we're just doing 7 minus 2, or 4 minus 2, or 5 minus 2, depending on the part. Okay, now we know that there are 10 that own a BMW, so 10 minus 3 minus 2 minus 2, so 3 is our answer. Whoops. Okay, for Toyota, there are 24 minus 5 minus 3 minus 2. So it's like minus 10, so 14. For Chevy, so that's this one, we got 19 minus 5 minus 2 minus 2, and we've got 10. All right. So this is why principle of inclusion and exclusion is important. It really helps us get some of the more possible ones on the inside here. One could go and do it logically, but it would just take a lot of effort. All right. So I hope that this video helps you understand the application of set theory a little bit better. And good luck.